Hey everyone, thanks for coming. We're in the design group that works with Bohler Engineering. I'm Liam.
I'm Tyler.
I'm Alec. I'm Kevin.
And our mentors were Megan, Charlie, and Ryan, who couldn't make it. So our project was to design a shopping center. In Albemarle County, Virginia. So this is supposed to zoom into it, but of course it doesn't work when it's supposed to. But for those who don't know, Albemarle County is located, it surrounds Charlottesville, approximately 150 miles northeast of Blacksburg. So our site was approximately 14 acres of undeveloped land, and it was zoned as a planned development shopping center in Albemarle County's comprehensive plan. Bend Creek Road surrounds our entire site, so it offered access points. And also, as seen in the existing conditions, there were lots of existing sanitary and utility connections that came into the site. So the goal of our project was to maximize the leasable area of the shopping center while following all design regulations and county regulations and keeping it as aesthetically pleasing as possible. So our design team came up with two different layouts. This is our first layout. The idea behind this was just to kind of put as many buildings in the northwest corner as possible. We ended up not going with this layout, so I'm just going to kind of go to the next one. And the idea behind this one was to break it up into two clusters, so it allowed more, so the traffic flow went easily, and also pedestrians would be able to park closer to the buildings, maximizing safety and convenience for them. There are three entrances that come off Bend Creek Road. One's here, one's there, one's up to the northeast. All the roads connect with each other and intertwine, including the access roads that run behind the two building clusters. And this design had approximately 3,000 more square feet of leasable area than our first design, and also cost less in our initial preliminary cost estimate. So we ended up going with this design. And now Tyler will talk to you about the grading and roadway design.
Like Liam said, I'm going to talk primarily about grading. Before we could start grading, we had to come familiar with all the county codes and regulations that were going to govern our design. So top one is a very specific one. We had to meet 4% maximum slope for the first 40 feet after tying in with an existing road. And then also we had our ADA requirements that needed to be met. So I'm going to walk you through our design process very quickly. Our first step was setting our finished floor elevations. The thought behind that was we would have a critical or a set point to work from, and then we would grade down so we would know the general elevation around these points. Next, we wanted to identify low points and possible stormwater management facility locations. So up in the north corner, that's the lowest point on the site, so we knew that water was going to be heading there. This is also another low point. So after knowing the elevations of our finished floors and where our water was going to be draining, we were able to effectively manipulate the grading. Okay. I'll actually get back. So this is our final grading plan. Overall, the site is very flat. This section right here is actually just a big plateau. So it was very difficult to, manipulate the water and grade everything to the required slopes. So we had to go through several iterations of our plan, but it finally came out to this. And then also, I want to talk about roadway design. Most of our roads are crowned. Up there we have a example of a crowned roadway, 13-foot lanes, 2-foot gutters. And then also here, because that was a very specific regulation with the 4% maximum slope for 40 feet, I included spot elevations of these tie-in locations.
So I'm going to talk to you all about our stormwater management plan. So if you just take a look at our site, the majority of the area is pavement and buildings. Roughly 90% of the site's impervious. So when you take a 14-acre undeveloped site and make 90% of it impervious, you're going to get a dramatic increase in peak discharge, and you're going to have to store a huge amount of runoff. So the goal of the project was to maximize leasable floor space, and that meant a lot of parking spaces. And basically, it left us with very little room for an above-ground detention facility. So we decided to separate it out so that we could use, basically because we did not have enough space, we ended up using 2 underground systems and 1 above-ground pond. So as you can see, the first underground system is on the southwest corner of the site. There's another at the north corner of the site, and the above-ground pond is on the east side. So once we had those set, we came up with our pipe networks and basically had inlets throughout the site convey stormwater to those locations. So to size our pipes, we used the rational method, and that basically consists of delineating the drainage area to each inlet, looking at the land cover to come up with a C value, computing the time of concentration, and ultimately getting the peak discharge, which we used to compute pipe diameter, and then verify that the minimum flow velocity was greater than 3 feet per second, which is what's required by Albemarle County. So for the sizing of the detention basins, we used TR55. So these were the pre-development watersheds that we delineated. Albemarle County is designated as hydrologic soil group B. And for all of the pre-development watersheds, we used the same curve number of 61. As you can see, the peak flows were relatively low. So this was the post-development watersheds. Basically the same process here, except now we have to compute a weighted curve number to account for the impervious areas. As you can see, the time of concentration dropped dramatically. The curve numbers bumped up quite a bit, close to 90, and our peak discharge jumped up dramatically. So with those peak discharges, we were able to compute the required detention volume, and with that, we were able to size our detention basins. So now Kevin's going to talk about the wet utilities.
So for our water mains, we used a loop system, which benefits us as that it covers it provides maximum coverage while also avoiding stagnant water. Seen in the green circles, we have our fire hydrants. We have 7 of them. And seen in these red circles, we have our 4 blow-off valves. And then seen here in our black circles are 2 air release valves. We calculated our peak flow and found our diameter of pipe to be 12 inches, which allowed us to tie into our existing utilities and also meet our required peak flow. These pipes were made out of ductile iron, and we met the requirements of having a minimum 3 feet depth and coverage. This is our existing water utility in the southwest corner. It is 12 inches of ductile iron pipe and is at 407 elevation. This is our existing utility in the southeast corner. It is also a 12-inch ductile pipe and is at an elevation of 407. So for our sanitary sewers, we have 2 existing utility connections. This is the one in the southwest corner, and it serves our buildings 1 through 6. We use a peak factor of 4 and calculate our average daily demand. We have our mains at 8-inch PVC pipe, and our laterals are 4-inch PVC pipe as well. These slopes met a velocity of 2 feet per second and 15 feet per second. These are our spots where water ran into our sanitary, and we made sure to have the distance. Here we also did the same process, and we had our mains of 8-inch PVC pipe and our laterals of 4-inch PVC pipe. These are our areas of conflict, and Alec will now talk about our
So our phase 1 E&SC plan focused on protecting downstream properties and existing infrastructure. We utilized silt fence, diversion dikes, construction entrances, and silt fence throughout the site. Phase 2 basically consisted of the same stuff, just getting phased out as it's being constructed. Still silt fence around the majority of the site, but now you have inlet protections on newly constructed units.
Are there any questions?
Looking back and kind of getting to play money more into back, would there have been any other ways to maybe value engineer the overall site, maybe more cost effective or anything you guys would have done different?
I think we could have placed inlets more efficiently. We had some very small drainage areas, some of our inlets.
A little bit too liberal.
Yeah, and that also, if we revised some of our grading, then we could have reduced inlets, and that would have definitely driven costs down. And then also potentially that smaller underground detention facility, if we connected that pipe run to the above ground pond, it ended up being enough volume in the above ground pond to actually cover that.
For your parking requirements, you guys have to make assumptions on the different types of uses for the different buildings. It's always a big problem with the shopping centers. Those assumptions you have to make kind of at the beginning. Or was that given to you maybe by the?
No, I think it was all,
I think it was stated in the Albemarle code for like shopping center for square.
yeah, it was per square foot, like there's a range. I think it was like the square footage divided by 1,000 times 4.75 or a range. And I think we just assumed it all as like, I think it just said it's like commercial or like shopping. I forget. They were different like parts.
I think we just assumed retail,
Yeah,
retail space.
Other questions for these guys? Good job.